Alrighty, so at this point, you should have watched the distributive property video. This was number 2 on your agenda. And so now here, what we're going to do is just take a look at a few notes on lined paper and then also in your book. So at this point, make sure you have your lined paper notebook out where you were doing your vocabulary for this chapter so far. So notice on your screen right now, it says number 7, distributive property. That's because we did 6 other vocab terms earlier last week. And so find where those vocab terms are. This is going to be number 7. We're going to add to it. And then also make sure at this point you have your book out to page 375. So pause the video, grab what you need, and then we're going to start. Alrighty, here we go. So again, this is a continuation of vocab we did last week. You had vocabulary terms of algebraic expression. You had coefficient, constant, like terms. We talked about those last week. We talked about 6 of them. So distributive property, number 7. So you're going to add to this, and you can pause the video at any time to get caught up, to make sure that you're getting everything written down before you keep going. So distributive property is when we multiply each term inside the parentheses by the number outside the parentheses. So I just gave you a few examples, and these were examples that you just saw in the video. So for example, just using letters, A on the outside, that variable, you would take and multiply that by everything inside, which is B plus C. Second example, 5, and you would take that 5 and distribute it and multiply it by everything inside the parentheses, 4 minus 2. And then lastly, negative 3 on the outside of the parentheses, you would distribute that and multiply by everything inside, x plus 9. So those are examples for sure that you're going to see. Now, there's one other thing that I want to do with you before we actually head to the book. So somewhere else on your lined paper, you can move down a little bit, or if you want a new sheet, let's just talk about this situation. This is going to sum up what you saw in the video before we start practicing other problems. So let's say, for example, 4 friends go to Michigan Adventure, and they each pay $20 for tickets and $5 each for pop. How much money do they spend all together? And so I put idea number 1 and I put idea number 2. And so I'm going to use the pen over here. Let's go red this time. And let's look at example or idea number 1. So if you have 4 friends that are going, and they're each going to buy a $20 ticket, right? And you're looking to see how much you're going to spend all together. Well, think about the ticket price first, right? 4 of you, $20 each. You know that's going to cost $80. Well, don't forget, you're going to also buy pop. So we're going to add to that the 4 of you times each one of you getting that $5 pop. So 4 times 5. Well, that's going to cost the 4 of you $20. And so if you think about then total cost, adding those together, it's going to cost $100 for your day at Michigan Adventure if that's all you plan on doing is getting tickets and pop. Okay, this is idea number 1. This is one way to think about it. Well, idea number 2, let's think about that as a distributive property type problem. And so what's in common here with idea number 1 when we start looking at 4 friends, $20 tickets, $5 pop? For each situation, you're multiplying by 4. And so that 4 would be the value that you're putting outside of the parentheses. Because then inside the parentheses, think about what you could put here to add together. Well, your $20 ticket and the $5 pop. Okay, and so if you were to think about, well, order of operations, hey, I can do everything here inside the parentheses. I can add 20 plus 5 and get 25. Yep. And then multiply it by 4. Absolutely. You're getting $100 again, right? So if you set it up as a distributive property problem 4 is that number that is in common with the entire situation. That's why it goes on the outside. And so if we think about taking that 4 and distributing it 4 times 20. Hey, look at that, an idea number 1, 4 times 20. Plus 4 times $5. Oh, 4 times $5 right here. So you're doing the exact same thing. They're both set up a little differently. Your mind might process it a little differently or think of alternate ways to solve it. But essentially, this is what's happening with distributive property. You're going to take that value on the outside of the parentheses and multiply it by everything inside the parentheses. Okay? So if you need to, you can take a minute. I would like for you to have this written down. I think it's a good way to different ideas of looking at distributive property. So if you need to take a minute and pause it, again, have this in your notes. The next thing we're going to do is head to page 375, and we're going to do some examples there. So I'll meet you back. Okay, so welcome back. We're on page 375. And so we're going to start to take a look at lesson 4 inside the book and look at a few examples. So let's take a look at this real world link. This is really what we were just talking about in your notebook just a few minutes ago, just a different example. So school supplies. Jordan buys 3 notebooks that cost $5 each. He's also going to buy 3 packages of pens for $6 each. So write an expression that shows the cost of the 3 notebooks added to the cost of the 3 packages of pens. So the 3 notebooks, $5 each. So if you look at the expression starting to be set up for you, well, what are you going to multiply by 5? Really, that's the $5 there if you think about the dollar sign. Well, you're going to multiply it by 3, right? Because you're buying 3 notebooks, $5 each, 3 times 5. And then times 6, well, you're buying 3 packages of pens, it's supposed to be a dollar sign, 3 times $6, 3 times 6. And so we just, again, use this example with the Michigan Adventure, and you're looking at, well, what does this expression have in common? What kind of stands out? Well, you're buying 3 notebooks and you're buying 3 packages of pens. So that 3, okay, number 2 here, is what we're going to see on the outside of the parentheses. That's what's in common with both. So it says, write an expression that shows 3 times the cost of 1 notebook and 1 package of pens. We know it's $5 each for the notebook, $6 each for the package of pens. Well, number 3 says then, to evaluate both expressions, what do you notice? So if I come back up to number 1 and I evaluate this expression, well, 3 times 5. It's going to cost $15 for the notebooks. And then 3 times 6, it's going to cost $18 for those packages of pens. So if I think about adding those 2 amounts together, it's going to cost me $33. Well, I should see this answer also in number 2 when I set it up as a distributive property problem. So if I think about, let me change colors here, taking this 3 and distributing it in 3 times 5 here is 15 plus 3 times 6 is 18. Yep. 15 plus 18, I'm still going to get $33. So you might also be thinking, well, okay, so why couldn't I just do what's inside the parentheses first and then multiply it by 3? That's absolutely fine. If you wanted to do 6 plus 5 and get 11, and then do 11 times 3, you're still going to get 33. Absolutely. So that way is fine as well. When I look at what I notice, so answering number 3, I'm going to say both expressions sorry, this pen sometimes gets really messy. Let's try this again. All right, both expressions for the same value. All right, let's try another one. Number 4. So suppose Jordan buys 5 notebooks that cost $3 each and 5 packages of pens that cost $1 each. Circle the expressions that represent Jordan's purchases. So 5 notebooks, $3 each, 5 packages of pens, $1 each. So if you notice, 5 notebooks, 5 packages of pens, that 5 is that common value. And so when I'm looking at my examples here, the ones that are going to work, the expressions that are going to work in this situation is definitely this last one, right? 5's in common between both. 5 goes on the outside. And then inside the parentheses, you could add together the $3 each for the notebook and the $1 each, for the pens. Well, think about distributive property with that, right? So if you were to take that 5 and distribute it like this, well, 5 times 3, 15. 5 times 1, 5. And so the other expression that represents that is this first one. Okay, you would add the $15 for the notebooks to the $5 that it's going to cost for the pens and get your total. You do not want the second one, the middle one, because if you notice, there's multiplication signs all the way between. You don't want to multiply every single number together. You want to take and understand how much it is for the notebooks, understand how much it is for the pens, and then add those costs together. So this is not going to work. Number 5, suppose Jordan buys 2 rulers that cost $1 each and 2 folders that cost $1.50 each. Circle the expressions that represent Jordan's purchases. So he's changing up what he's buying. 2 rulers, $1 each. 2 folders, $1.50 each. Okay. So I'm hoping when you look at this right now that you say, okay, yep. This last one, 2 times $1, 2 times $1.50, and add those together. But then that is represented also by this second one, which shows distributive property. We are not going to use the first. This time, there's adding signs between every value. You don't want to take the 2 rulers plus $1. That doesn't make sense. Or the 2 rulers plus $1.50. You want to be able to make sure you have that quantity multiplied on both and then add together. All right, so we're going to move down to page 376. And like I said, you'd done some of these in 6th grade last year. So I'm hoping as we start to look at these a little bit, it's looking familiar. Now, obviously this year, you take that next step up. And so you're going to start to see some integers. And so you'll start to see negatives in these examples. So if we look at the got it at the bottom of page 376, let's start figuring out how these are going to work out. So the one thing with distributive property is you can do them, absolutely 2 different ways right now, A, B, and C, because there's no variables here, right? We are going to start to see variables. And once we do, there's really going to be only one way you can do it. Right now, I'm going to show both ways. What I mean by that is this first one, okay, letter A, 5 times, and in parentheses, -9 plus 11. I want to be able to use distributive property, or I can actually use order of operations in this case to find out my value. So let's first start off with order of ops. So I'm going to call this first way, okay? If I do order of operations, I'm going to do -9 plus 11. So if I use my integer rules here, I would have 2. +2. Opposites, okay, 1 positive, 1 negative, you subtract, take the sign of the higher number, which is 11, +2. Well, then I'm going to multiply that by 5. And if I do that, 5 times 2 is 10. The second way, and I should get the exact same answer, is if I do distributive property. So I'm just going to rewrite this for a minute. and show taking that 5 and distributing it in. So I'm going to do 5 times -9. 5 times -9. I'm going to put the plus sign here because I'm not done, because with this 5 on the outside, it has to distribute to everything inside. So it also has to get multiplied by 11. So 5 times 11. All right. So if we use distributive property, now we need to think about our integer rules with multiplication. So 5 times -9. One negative when you multiply makes that value negative. So -45 plus 5 times 11. These are both positive, 55. Okay. So then now I'm left with -45 plus 55. Again, with my integer rules, if I have opposite signs here, I need to subtract and take the sign of the higher value. My answer here is also going to be 10. So they both match. I can do the way with order of operations, or I can show distributive property. So I wanted you to see that. If you don't have any variables, absolutely you can do it either way. Letter B, 7 times 10 minus 5. I think the easiest way to look at this is definitely order of operations. If you do inside the parentheses first, 10 minus 5 is 5. And then lastly, you're going to multiply that by 7. So 7 times 5, 35. Letter C, 12 minus 8, and then times 9. Same thing. I'm just going to do order of operations. I know most of you are going to do that if you don't see the variables. So let's just continue. 12 minus 8 is 4. And then 4 times 9, even though the 9's on the opposite side there on the right, that's okay. 4 times 9 is going to give you an answer of 36. And so again, it's absolutely fine if you want to use order of operations, but I did just want to show you the one example where you could do it either way. You could show distributive property and get the same answer. So again, we're going to keep going here. And now we're going to start to take a look at those examples with the variables. And so now on the bottom of page 377, you are going to see those variables appear. You are going to start to see that, hey, when I look inside the parentheses, I can't do order of operations anymore because I don't know what the variable is. I have to be able to distribute with the variable. All right, well, let's try a couple. Letter D. So we've got 6 times a plus 4. And so that 6 has to multiply by everything inside the parentheses. So if you've noticed, I'm drawing these arrows to each number. It almost looks like in some respects you're starting to draw a rainbow. You're making sure that that value on the outside is getting multiplied by everything on the inside. And so I force myself to do it just to make sure, like, yep, I know I got to do 6 times A. Okay, but I also have to do 6 times 4. I don't want to forget a number. And so I need to make sure that 6 gets multiplied by everything inside. And so if I do that, I now have 6 times A plus, and what I do is I just copy that symbol that I see, which is an adding sign, into my problem. And now I'm going to do 6 times 4. So 6 times A, come over here, 6A, so I'm just going to put it together without the multiplication sign in between, plus 6 times 4, 24. Now, this is it. This is as simplified as you can get this expression. You cannot add these together. So we talked about a vocab term that was like terms. And like terms are when they're the exact same variable. Well, 24 doesn't have an A next to it. So these are actually considered unlike terms. 6A is its own term, 6 and an A attached with it. And then 24, again, that's its own term. It's a constant, actually. So you can't add these. Don't say 30A. That won't make sense. They are not considered like terms. And so if that's still confusing to you, that is coming up in lesson 5 when we start looking at like terms and how combining and what that means. For right now, this is your simplified answer. Okay, let's take a look at letter E. So they're going to throw you this little curveball here, and they're going to put the 8 on the right side of the parentheses. And that's okay. If you are someone who doesn't like to see it that way, it's confusing to you, you could actually write this with the 8 on the left. So you're just going to move it over, but keep the inside the same, right? Some students struggle with that. And so again, if it's confusing when you see it, move the 8 to the other side of the parentheses and you can work it out this way. So I'm still going to do distributive property. You see variables inside there. You see an M and you see an N. And so I have to distribute. I can't do order of operations. I can't add what's inside the parentheses together. So I'm definitely going to make sure I multiply 8 times M and 8 times 3N. So here we go. 8 times M looks like this, plus 8 times 3N looks like this. Oops. Well, that doesn't look right. Maybe. There we go. Okay, so simplified 8 times M. 8M. I'm just getting rid of the multiplication sign in between. Plus 8 times 3N. 8 times 3N. 8 times 3, 24. And then bring the N with it, 24N. I'm done. This is as simplified as I can take it right now, okay? So before we get into problems like F and G, what I want you to do is go down to independent practice here. So keep scrolling. And I want you to try a few and see if you're getting the hang of it to start with. We're going to do some easy ones. So I want you to try on independent practice. This is going to be page 379. You're going to do number 1, 2, 3, 4, 5, and 6. Now notice, okay, there's no variables here, so you can do order of operations. Just watch, you do have negatives in here, and so you're going to want to be careful with your integer rules. Try those. And then, let me see here. These are ones I think we need to do together. So I'm going to have you just start with, just double check guided practice here. Yep. I'm going to have you just start with those 6. Okay. So work those out. I'll meet you back here. You'll unpause or pause it right now. I'll pause the video. Try those. Unpause it when you're ready to check your work. Okay, so let's start talking about these. So I said you could use order of operations. Now, again, the biggest thing you see here is there's going to be integer rules that come into play. And so these integer rules that we learned in chapter 3, they really start to become more prominent with add, subtract, multiply, divide, starting with chapter 5 and starting with distributive property here in this lesson. So number 1, 5 plus 6, I did inside the parentheses there and got 11. And then, oops, I multiplied by the 3 on the outside. And so if I do that, 11 times 3 is 33. Number 2, 6 plus 4 is 10. And then I'm going to multiply that by the negative 12. If I do 10 times negative 12, I get 120. So 10 times 12 is 120. It's also negative. One negative when you multiply is negative 120. Number 3, 9 minus 4 is 5. And then 5 times negative 6 is negative 30. Again, one negative when you multiply is a negative answer. Number 4, -6 plus 4 in parentheses is -2. -2 times the 5 on the outside is -10. One positive, one negative multiplied equals a negative, -10. Number 5, 8 minus 7 is 1. 1 times 4 is 4. Number 6, this one is tricky. Now, I want you to look inside the parentheses here, 5 minus 7. Taking 7 away from 5 is not going to give you a positive value. Okay, you're taking more away than what you have. So if you have $5 in the bank and you take out 7, out of the bank, that means you're at -$2. Okay, so think of it as, since this is subtraction and you're taking a bigger number away from a smaller, this needs to be leave change opposite. This needs to be 5 plus a -7. What I did is LCO so that you see that. -2. -2 times -3 is a +6. So as you're going through these answers right now with me, if you have mistakes, especially with the negatives, then that is where you'll need to definitely make sure you take some time and you go to that quiz and you practice your integer rules. You look back at what Mr. Terpstra gave you in chapter 3 in any of the past videos, and you look back at the integer number line. You look back at the integer rules that he gave to you in that chapter and use those. So if you're struggling, just keep those resources in mind to keep practicing. In fact, maybe I can even give you an integer flashcard type of Quizlet where, once again, you're just constantly always skill and drill, add, subtract, multiply, divide your integers. All right. So we're going to do a couple more and then we're going to end for today. So we're actually going to come back up and we're going to look at those other two problems I skipped a minute ago. Okay. So we're going to go back to the got it on page 377. So let's take a look at letter F. So I see -3 on the outside, and I'm going to need to multiply that by y minus 10. Okay, so this one's also tricky. You have a negative on the outside of the parentheses, and you have a subtraction sign on the inside of the parentheses. With distributive property, I would encourage you, anytime you see subtraction inside your parentheses, especially if you're going to multiply by a negative value on the outside, that you do LCO. So I'm going to rewrite this. So if you do leave change opposite on the inside of the parentheses, this is going to become leave the y, change to addition, opposite. This is a -10. This is what you are going to use to show that distributive property. All right. So I rewrote it for you so it's easier to see where your negatives are. And so now let's start solving it. So we're going to take -3, and since I kind of didn't give myself enough room, I'm going to do an upside down rainbow. -3 times y. -3 times y. It's bad too again, sorry. And actually that's a really light color. So -3 times y. Plus, I'm just copying the adding sign down. -3, we have to also multiply that by -10. -3 times -10. -3 times y. -3y. I take away the multiplication sign in between. Plus -3 times 10. Sorry, keep making that mistake. Two negatives multiplied together is a positive. Plus 30. -3 times -10, positive 30. Lots of negatives, lots of understanding of leave change opposite and your integer rules. Okay, let's look at letter G. 1/2 times W minus 4. So I'm going to just show what I'm going to distribute. I'm going to take and distribute that 1/2 to both numbers inside and variable. And so now I'm going to do 1/2 times W minus 1/2 times 4. Okay, so 1/2 times W, 1/2 W minus, subtract, 1/2 times 4, half of 4, 2. So I said anytime you see subtraction inside the parentheses with distributive property, you should do LCO. I forgot to do that right off the bat, but you could also show it here. You could say, or this answer would look like this. 1/2 W plus a -2 if I were to do leave change opposite. Both of those are the same answer. Okay. I think we're going to end today and leave off at this point and then come back tomorrow and do some more, just kind of skill and drill your distributive property with different types of problems, non-variables, variables, positives, negatives, and really start to feel more comfortable with your distributive property. So we're going to stop here. That means the next thing on the agenda with your time remaining in class, if you still have time, you're going to take a look at what BuzzMath has to get done still, and then also take a look at maybe getting started in ALEKS, one or the other. Have a great day, and I will see you tomorrow.